We are live. Okay, 9:24. Today we're talking about quadratics. Fancy word for x squared functions. Okay, and they're called quadratics from the quadratic formula. And the quadratic formula only works on x squared. Okay, the quadratic formula only works on x squared. It doesn't work on anything else but x squared. Okay, don't try and use it on x cubed. It won't work. Okay, so example 1. Graph this parabola. Okay, so it's in standard form. So the first thing, the vertex. Let's find the line of symmetry before we do that. X equals negative b over 2a, right? So I'm going to go down here and go, okay, x equals negative b over 2a. A is 1, b is negative 2, and c is negative 8, right? So I'm going to get my line of symmetry or axis of symmetry to be a negative 2 over 2 times a 1, which is a 2 over 2, which is a positive 1. So I know the axis of symmetry, the line of symmetry is at 1. So I'm going to go ahead and just draw it in. Put it in there at 1. Okay. There it is. At 1. Now, the vertex must be on that line, correct? So let's plug it in to get the vertex. So the vertex is now, it's my negative b over 2a comma f of negative b over 2a, right? Which means plug it in, right? Plug it in. So we're going to go y equals a 1 squared minus a 2 times 1 minus 8. So I plug it in to get the corresponding y value. So if I plug it in, I'm going to get a 1 minus 2 minus 8 makes a negative 9. Okay, it makes a negative 9. So my vertex is at 1, negative 9. Okay, I'm going to put that on my graph too then, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Let's do the y-intercept before the x-intercepts because the y-intercept's easy. Okay, the y-intercept, if it's a y-intercept, it lies on the y-axis. The x values are 0. Does that make sense? A y-intercept, think about this. The y-intercept is on this line. The x value is 0 on this line, so just let x equal 0. So the y-intercept, we're going to let x equal 0. So that's easy. I'm going to go, okay, y equals, don't really need to do it. You guys agree with that? I mean, you can do, I mean, pretty much, I don't need to do this. You already know it's negative 8. Agree?
Oh, yeah.
Okay, so it's got to be negative 8. So my y-intercept is 0, negative 8. So I can graph that point. And because we have a line of symmetry and axis symmetry, we have another point right there, right?
Oh, yeah.
Why not, right? So because it's an axis of symmetry, we got another point right there. Now, to get the x-intercepts, there will be 2 of them, right? We're going to let y equal 0. So we let y equal 0. And we'll either factor if we can, and if we can't, we have to use the quadratic formula, okay? So factoring's nice. Factor quadratic formula, right? Factoring. So if I go 0 equals x squared minus 2x minus 8, I can factor that pretty easily, right? Parentheses, 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 x, right? Negative 4, positive 2, right?
Right.
Add 4. So if I have my mini equations, right? My mini equations, I have x equals 4 and x equals negative 2. Those are points. We'll call it 4, 0 and negative 2, 0. Okay? And I'll just graph those. 1, 2, 3, 4, and 1, 2. Okay? And then all I have to do is just scratch in my parabola. I've got it. Okay? Now, yeah, you can say, gosh, Mr. Davis, I can just use the calculator to get these. You're right. You can. However, and maybe not in here. But however, in college, they're not going to let you use a calculator, right? So we're going to need to know how to do it, okay? Okay, you ready to turn the page? Turn the page. Trish, you tell me when you got it. We got it? Turn the page, right? Now, example 2. Rewrite x squared minus 2x minus 8 into vertex form. Oh, all right. Let's see if we can do that. This is going to take some brain power. Okay, you ready? First, let me rewrite this as y. Just easier. Now, 2 ways to do it. Probably the easiest way is to take the graph, because it's the same equation, isn't it? If that's my graph and the vertex is at 1, -9, so I know the vertex is at 1, -9, and I want y equals a times x minus h squared plus k, then we can just plug it in, right? Let's do this the easy way. Always, right? Always the easy way, anytime we can. So, ready? How about a y equals a times an x minus 1 squared minus 9. Here's my h and my k.
Wait. Okay.
Now, to get the value of a, we're going to plug a point in and solve for a, okay? So, we have a point of -8, right? So let's plug in the point 0, -8, where my x value is 0, my y value is -8. We kind of did this when we did the rockets, right? So I'll plug my -8 in for y, plug my 0 in for x, and I should be able to solve for a. Okay. So let's see, plus 9, I've got a 1 equals a times 1 squared. -1 squared. But it doesn't really matter, does it? Because that's really going to be a 1. So I've really got a 1 equals a, right? So my answer in vertex form is almost here. Almost have it. Let's go ahead and rewrite it with an a. Is a y equals 1, because that's my a, x minus 1 squared minus 9. There we go. Okay, how am I doing? Example 3. Okay, solved. Bummer, it doesn't factor. Now what do I do? Quadratic formula. A is 1, B is 2, and C is 5. Negative b plus or minus b squared minus 4ac all over 2a, right? Right? Zoom it in a little bit. Oh, I can't because I'm recording. Thumbs up? 2 thumbs up? Easy? So, are you ready? Negative b. So I'm going to go -2 plus or minus square root of b squared, which is 2 squared minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. Okay? How am I doing? -2 plus or minus square root of 4 minus 20 all over 2, right?
420.
Oh, you guys are funny. I had my third period, just get it, because, you know, freshmen, sophomores, I said, go ahead, just say it, 69. Just say it, 420, just say it, get out, and can we move on? Right? -16 over 2, but that's going to be an I answer, correct? So, a little side work, we know that the square root of -16 is the square root of 16 times the square root of -1, right? Right? We know the square root of -16 is going to be an I answer, which is going to be 4i. So, scoot this up here. Let's go -2 plus or minus 4i over 2. Okay? which again, we got to have a real plus our imaginary, right? Negative 2 over 2 plus or minus 4 over 2i, right? Which would simply be a negative 1 plus or minus 2i, okay? Those are the zeros. They're not x-intercepts, right? Those are zeros. Those are not x-intercepts because they're i's. But they're definitely zeros, okay? Okay, ready? Am I going fast enough or too fast? Am I good? Okay, scoot it up. Okay. All right. Farmer John, or Farmer Bill, wants to make a rectangular garden fence in her or his garden. She has 80 meters of fencing for 3 sides of a rectangle and uses the fence as the 4th side, okay? Find the maximum area and the dimensions for a garden. So right off the bat, we got 80, right? It's a rectangle. So if I put some of the fencing here and some of it here, okay? Now, let's think about this. I got 80, and I'm going to show it using regular numbers, and then we'll use x, okay? Got 80, right? What if I put 20 here and 20 here, right? How much goes here?
40.
How'd you get that?
Because you already have one side.
So you went that and that, and you subtract it from 80, right? So hypothetically, let's just put some other numbers in here, okay? This is what we were talking about earlier, right? These are hypothetical numbers. This is 10 and this is 10, right? How much goes here?
20. Freak.
20 from 80 has to give you 60, right? Does that make sense? So you added these two and subtracted it from 80, right? So you added these two, you went 10 plus 10, you went 2 10s, you went 2 of these, subtract from 80, right? Now the difference is we don't know what side this is. It might be 10, it might be 10, it might be 20, we don't know. But let's just call it W. So then the length is going to be 80. The length is going to be 80 minus 2W, right? You got 80 meters of fencing, but so much here, so much here. What's left over is going to be 80 minus that, correct? Okay, this gets pretty easy from here because we know area of anything is going to be length times width because it's a rectangle, right? So area of this fence is going to be W times 80 minus 2W, right? Or area is equal to 80W minus 2W squared. All right, now, that's a parabola. That is a parabola. And if we're to graph it, I want to show you the graph, okay? It's a parabola, and its parabola looks something like this, okay? Now, think about this. Think about this, okay? A super skinny fence that's super long would have very little area. So this is my width, this is my area. Does that make sense? A super wide with very little length would have, again, a small area, right? So if the width is really big and the length is small area. So the best possible dimension is right there, which happens to be the vertex of my parabola. Well, that's easy. I can find the vertex of my parabola pretty easily. So I want to find the vertex from that. And that should give me the best. That should give me the best. So my vertex is going to be, let's use my negative b over 2a. So I'm going to slide over here. I'm going to use, okay, w is equal to my negative b over 2a because I'm looking for the vertex. When I get done, I'm going to graph it, okay, so you can see it. So negative b, so my width is going to be my negative 80 over 2 times a negative 2. There's my b, and there's my a. b is in front of the w, a is in front of the w squared. So that's an 80 over 4, right, which is 20, so the width is 20. So that means the best fence is going to be 20 yards by 40 yards. Okay. Now, let's take a look at this on the calculator. I think it's worthwhile to see it on the calculator. Okay, so put in the calculator. Let me put my equation clear because I want you to see this. It's kind of a cool illustration. 80 x minus a 2x squared, right? Window, I'm probably going to have to go, let's go 45 there, and a volume, let's go 500, and let's just see if that works, okay? Oh, got to see more. Window, got to go higher. Let's make this 1,000. Okay, here it is. Okay, now I want to show you something. Okay, this does not look like a rectangle at all, but it represents width. These are my widths, a corresponding volume, right? So as you trace it, it's kind of cool, I think. But I always think math is cool, but that's me, right? So if I trace it, if the width is 10, there's your volume, right? If my width is only 5, pretty skinny, right? Skinny but long, there's my volume. So I'm losing volume, right? It makes sense. The very best, of course, is at the top when the width is 20 and the volume is about 800, okay? And of course, as my width gets bigger, super wide but super skinny, I start to lose volume again, okay? Nice application. All right, now, here's the